Go.
Hi, I'm David Smith. I'm a faculty member in the physics department and a member of SCIPP, Santa Cruz Institute for Particle Physics. I am not a particle physicist. I study high energy radiation in the universe, most recently and most commonly now from lightning. And it's a relatively new thing that lightning makes gamma rays and high energy particles of various kinds. So it's a very exciting field to be in because it's brand new. It's something where we're still breaking ground and discovering the basics, and I find that very exciting. I came to Santa Cruz in 2003 to do astrophysics, which I am still very interested in, and there are other fields of research like astrophysics and solar physics where I might still take on a student now and then. I work with typically 3 or 4 undergraduate students a year in my research group. And where they come from is, it's the folks who come and ask me. So if you come to my, if you send me an email and make an appointment, if I have room, if I have a project, we'll work together. This is not a competitive process. And so I really encourage everybody to just come and talk to me. Sometimes there'll be a project available, sometimes there won't. But I really like to meet with students and talk, and I like most faculty, I love to talk about my research. What students do in my group varies from data analysis to simulation to actually building and even sometimes helping design instruments. We design a lot of our own instruments in the group between me and the graduate students and the SCIPP engineers and the undergraduate students. We work together to make improved instruments for detecting high energy radiation very quickly because lightning goes by very fast. And we deploy them to sites all over the world because Santa Cruz is a lousy place to see lightning. And then the data comes back, we analyze it, and you have to run some interesting computer simulations in order to interpret what you see. The gamma rays rattle around in the atmosphere, and you have to simulate that to understand what happened in the first place. Why study this? That's a question you always get in any field of research, unless you're an astronomer where everybody knows it's cool and everybody knows that's why, so you always get a free pass. But if you're doing anything else, people are going to ask you why. And, part of this is, it's just cool. Why would lightning do this? Why would it accelerate particles to really high energies? And there's a lot more detailed questions that flow from that. It's also true that sometimes, very rarely, lightning makes a gamma ray flash that's so bright that you can see it even from a satellite in orbit 400 miles away. And we have a lot of those data. So, if a student was interested primarily in data analysis, they might be working just on satellite data instead of on the instruments we build in the lab. But these events that are so bright, they're called terrestrial gamma ray flashes. They are so bright that if you were in an airplane and you happened to be flying right by the lightning when it happened, you could be toast. That there could be a radiation dose that could sicken or kill somebody. Now, that's probably never happened because they're rare events and pilots don't like to fly in thunderstorms. But there's still some level of concern about this radiation for aircraft and in real life. So one of the things we're trying to do is not just get behind the physics of what's happening, but also make sure that pilots aren't putting themselves, their passengers, in danger, particularly research pilots who fly into storms on purpose. They're pretty much the only ones. Join the research group, see the world. We deploy to very interesting places, to Japan, to Mexico, to towers, to tropical areas in the future. We have some plans coming up for building many small instruments, deploying themselves to high schools. That would be a nice chance to work maybe on some outreach as well as science. So if this sounds interesting, I encourage you to contact me and we'll talk. Thank you.